incoming exam. So this weekend, exam 2. So exam 2 is coming up. And also maybe some of you already started the practice questions. If you have any question, we can talk about it. Okay, anyone has any other questions? So today we're going to keep talking about radicals. Square root sign. But we want to solve equations involve radicals, right? Let's see this symbol. Right? So we have this square root sign or radical sign, and the index is no. If it's no index, that means the index is 2, the square root. Right? And under the radical sign is called a radicand. Radicand. And this is a radical sign, of course, right? So how do we solve this? We would square both sides, because square root will get 2x plus 1 equals 1. Then minus 1 on both sides, 2x equals 0. That means x equals 0, right? So 0 indeed is a solution for this. 2 times 0 is 0. 0 plus 1 is 1. Square root of 1 equals 1. That's the only solution. Right? So 0 is the only solution. Now let's see this one. This one involves cubic root, right? So the index for this one on the right-hand side is 3. So the cubic root of 4x plus 7. This is still the cubic root equation. And something we will encounter is called extraneous root or extraneous solution. Because when we square both sides, right, like this one, but this one is special, we don't get extraneous solution. But sometimes if you have something else, we get extraneous solution, which means extraneous solution means when we square root, when we square, the square, square change negative to be positive, right? So because of that, it will cause some untrue solution. The solution is fake. So that's why we need to go back to check. When we solve the equation with the square root signs, we need to go back to check to see if it's indeed a solution. Sometimes it's extraneous solution. Let's see this example. You see, we would square both sides, because when we square, we will free x plus 10 from this square root. So we square both sides, we get x plus 4 squared equals to x plus 10. Right? Then we expand on this side, we get x squared plus ax plus 16 equals to x plus 10. Then we move x plus 10 to the left-hand side because we want the right-hand side to be 0. And we get x squared plus 7x plus 6 equals 0. Or this can be factored. X plus 1, x plus 6. So we get two solutions. -1 and -6, two solutions. So what do? We plug -1 and -6 back into the equation to see if it's true. So we plug in x equals 1. We plug in x equals 1, so the original equation stays true. Well, let's go back to check. If x is -1, the left-hand side, we get -1 plus 4, which is a positive 3. -1 on the right-hand side, -1 plus 10, which is 9. Square root of 9 is 3, so that's true. 3 equals to 3. So -1 indeed is a true solution. But now let's plug in -6. -6 plus 4 is -2. If we square root something, it has to be positive. It cannot be -2. So that's on the left-hand side. Left-hand side, we got -2. Let's see the right-hand side. Right-hand side, we have -6 plus 10, which is positive 4. Square root 4 is 2. So that means -2 equals 2. Of course, it's not true, right? So -6 is not a true solution. But why it showed up? It showed up because we square both sides. So when we square both sides, something changed. So we call that one extraneous solution. So -6 is extraneous solution, a fixed solution. So we reject it. So the solution for the equation is x equals to -1. Solution for this is x equals to -1. Does it make sense? Anyone has any questions? Go over again. Okay. Go over, you mean to check the solution or to solve this equation?
To solve this equation.
Okay. So let me ask you, if this one was in front of you, right? So what would you do? You would want to get rid of this square root sign, the radical sign, isn't it?
Yes.
Yes. So how do you get rid of this? You by squaring it, right? Because square and square root are opposite operation. They cancel each other out. Does this step make sense? Square both sides. So we get x plus 4 squared equals to x plus 10. Okay, so this makes sense. Now, so we just expand, right? So x plus 4 squared is x squared plus ax plus 16 equals to x plus 10. Then we move x plus 10 to the left-hand side, becomes a negative. We simplify, we get x squared plus 7x plus 6 equals 0. We put it in a factor form. So this is quadratic equation, right? How do we solve quadratic equation? We can always use quadratic formula, or if we can factor it, we would factor. So factoring this, we get two solutions. So far makes sense? Okay. Then the rest is just to check. Anyone else has any questions? Okay, let's see more example. Let's see this example. We have x plus square root of x plus 2 equals to x. We want to single out square root of x plus 2. So what do? We would subtract 4. We would move this 4 to the right-hand side. So then this changes to be square root of x plus 2 equals to x minus 4. Now, when we square both sides, we'll get rid of this square root sign. You see, that's exactly why we don't square both sides in the very beginning. If we square both sides, we won't be able to get rid of the square root sign. So we would single out the square root signs. Now we square both sides. Square root of x plus 2 becomes x plus 2. X minus 4 squared is x squared minus 8x plus 16. Then we want to make one side to be 0. Move everything to the same side. So we get x squared minus 9x plus 14. This can be factored again. So x minus 2, x minus 7. So we get two solutions. Get 2 and 7, two solutions. Now we want to check. If we put a 2, so 2 plus 2 is 4. Square root of 4 is 2. 2 plus 4 is 6. That means 6 equals 2. So we see 2 is not a solution. Interesting, isn't it? Now let's check 7. 7 plus 2 is 9. Square root of 9 is 3. 3 plus 4 is 7. 7 equals 7. Yes. So 7 is a solution, but 2 is extraneous solution. So we reject 2. So solution is 7. Okay. So first we want to single out square root sign, the radical sign. Then we just try to solve it. So this is then when we square it become quadratic. So solve quadratic equation, we want to change one side to be 0 because we can use factor form or we can use quadratic formula. Anyone has any questions? Now let's see this one. This one is a cubic root. So the index is not 2 anymore, it's a 3. Anyone has any suggestions? How do we get rid of this cubic root? Because basically we can think 6x plus 4, we want to free 6x plus 4. So we want to get rid of this cubic root. Anyone has any suggestions? Getting rid of square root with square. Getting rid of cubic root with cube. Okay. We raise both sides to the third power. Right? So we raise both sides to the third power. To the third power, yes. So raise both sides to the third power. So power 3 over index 3 is 1. So we get 6x plus 4 equals to 4 raised by 3. 4 raised by 3 is 64. So subtract 4, 6x equals 6, 60, x equals to 10. Well, this one, we didn't square both sides, right? If we didn't do square or fourth root, we did not raise it to an even power. So we don't have to go back to check, right? Only when we raise something to an even power, we change the negative to be positive, we have to go back to check. So this one, 10 is the solution, right? If you want to check, 10 times 6 is 60. 60 plus 4, 64. Cubic root of 64 is indeed 4. Okay, so when the index is odd, we don't need to check. When the index is even, we need to plug back in the solution to check. Anyone has any question? Let's see this one. So we have square root on one side, we have r minus 1 on the other side. Well, let's square both sides, right? When we have square root, we want to square both sides. Square root cancel each other. So get r minus 1 equals r minus 1 squared. R minus 1 squared is r squared minus 2r plus 1. Then we move this one to the right-hand side. We get r squared minus 2r minus r, that's minus 3r. 1 plus 1, that's plus 2. We can factor this to be 1 and 2. So we have two solutions. It looks like we have two solutions. Now let's check 1. If r is 1, 1 minus 1 is 0. Right? Left hand side is 0. And the right hand side is 1 minus 1, also 0. So 1 is a solution. What about 2? 2 minus 1 is 1, square root of 1 is 1, 2 minus 1 is 1. So both are solutions. Right? Check 1, we have 0 equals 0. It's true statement. It's a solution. Check 2, we will have 1 equals 1 is also a solution. So we have 2 solutions for this. Anyone has any question? Well, let's see this one. If this one equals 0, we don't want to square right away. We want to single out the radical expression. Okay? So which means we want to move negative k plus a to the right-hand side. To the right-hand side, we got a k minus 8. Now we square both sides. Square left-hand side, we have k plus 64. Square right-hand side, we have k squared minus 16k plus 64. Or minus 64 on both sides, this is 0. Then we have k squared minus 16k minus k, that becomes minus 17k. Now we factor out a common factor k. So k squared minus 17k written as k times k minus 17. So we have 2 solutions, k equals 0 and 17 by using 0 property. So if we plug in 0, we see 0 plus 64 is 64. Square root of 64, square root of 64, right? Well, if k is 0 here, we got into a problem. 0 minus 8 is negative 8. Right? So of course it's not a solution. So I always need to go back to check, especially when we have 2 solutions, right? Almost guaranteed, you know, it's one of them is not, it's the extraneous solution. When we do square root, fourth root, sixth root, like that, when the index is an even number. Anyone has any question? Okay, let's see this example. Well, cubic root of 9x minus 1 equals negative 5. Of course, we want to move negative 1 to the other side, to the right-hand side. Negative 5 plus 1 will get negative 4. Now, we want to put a cubic sign, right? We want to raise both sides to the power 3. Raise the left-hand side to power 3, we get 9x minus 1. The right-hand side, negative 4 raised by 3 is negative 64. Then solve for x. 9x equals negative 63. X equals to negative 7. So when the index of the radical sign is an odd number, we don't get extraneous solution, right? Only when we square 4th power, 6th power like that, we have to be careful, because by doing the process, we change the negative to be positive. Let's see this one. Well, we want to square both sides, right? When we square both sides, we get 3u plus 7 equals 5u plus 1. So that means 2u equals 6, u equals 3. We can go back to check. If u is 3, 3 times 3, 9. 9 plus 7, 16. 9, right, 9 plus 7, 16. Square root of 16 is 4. Then 9 know which one I'm checking. 3, right? Yeah. 3 times 5, 15. 15 plus 1, also square root 16. It's also 4. So 3 is the solution, right? Okay. Sometimes we reach the radical signs in fraction exponent. Right? Let's see this. Square root of 6x plus 1 can be written as 6x plus 1 raised by half minus 3 equals to 4. First, we move negative 3 to the other side. So 4 plus 3 becomes 7. Now to get rid of half square root, we want to raise both sides to the power 2. So now raise both sides by second power or square both sides. So we get 6x plus 1 equals 7 squared equals 49. So that means 6x equals 48 and x equals to 8. Only written differently. The idea is still the same. Let's see, this one raised by 1/3 is same as cubic root. Right? The index is 3. Cubic root of 12x minus 5 also can be written as 12x minus 5 raised by 1/3 power. We want to raise both sides to the power 3. 3 times 1/3 becomes 1, or 3 over 3, right, becomes 1. And negative 5 cubed, that's negative 125. Right. So by doing that, we get 12x minus 5 equals to negative 125. So 12x equals 120. We add 5 on both sides, right? Then x equals to negative 10. Anyone has any question? Let's see this example. This is a 4th root, so the index is 4. What can be written as exponent fraction? So what do? We would raise both sides to the power 4, because 4 times 1/4 becomes 1. So this is 5x minus 4 equals 2 to the plus 4th power. 2 times 2 is 4. 4 times another 4 is 16. So solve, we get x equals to 4. Anyone has any question? Okay, now let's see how do we use in life. Let's see this example. Reed wants to have a square garden plot in his backyard. He has enough compost to cover an area of 75 square feet. Use the formula S equals the square root of A to find the length of each side of this garden. Round your answer to the nearest tenth. Okay, square garden. The side is called S, so the area equals S squared. Right? Or S can be written as is the square root of 8. And in this case, the square root is the square root of 75. Square root of 75 can be simplified as 5 radical 3. So that's it. Does this make sense? Anyone has any question? Let's see next example. A construction worker dropped a hammer while building the Grand Canyon skywalk 4,000 feet above Colorado River. Use this formula, T time equals square root of h over 4, to find out how many seconds it took for the hammer to reach the river. Okay. So if we plug in T, the square root of h is 4,000, right? Then divided by square root of 4,000 divided by 4. So 400 is 20 times 20. Then we have 20 square root 10 divided by 4. 20 divided by 4 is 5. So time is 5 square root of 10. Anyone has any questions? Okay. The next section is using radicals in functions. So we have functions involve radicals. Let's say f of x equals square root of 3x minus 1. G of x is cubic root of 2 minus 8x. Those are two examples. Right? With functions, of course, we can evaluate, right? We can find its domain. We can draw the graph. If we want to find a value, some values, f of 2, we would just plug in x to be 2, right? And calculate. If we plug in x plus 2, we just put an x place. Let's just change the x to be x plus 2. So plug in, right? So the first one we get this one, square root of 3x plus 2 minus 1. Simplify a little bit, we get square root of 3x plus 5. Well, now the input is 3 minus x instead of x, the input. So we substitute x with 3 minus x. Then we just multiply, we combine like terms. So we get a square root of 8 minus 3x. Oops. F of x is square root of 3x minus 1. G of x is cubic root of 2 minus 8x. So those are involved, those functions involved with radical signs. Evaluate this function. We just plug in x, right, with whatever the input is. Well, the input now is x squared, so we just get x to be x squared. X to be k squared plus 3. We just change the place of x to be k squared plus 3, then simplify it. Simplify, we get square root of 3k squared plus 8. Lesson application. The height of a drone is given by this function. H of t equals the square root of 30 minus 2t kilometer. T hours after 12 p.m. So the question, what is the height of John at 4:45 p.m., right? The variable t represents time, and time starts at 12. So at 4:45 p.m., so what's time? Time is 4 hours, 45 p.m. But 45 p.m., we need to change to be hours. Otherwise, we wouldn't be able to calculate. So how do we change? We change 4:45 to be 4 hours plus 45 divided by 60, right? Because 45 is minutes. 45 minutes divided by 60 minutes, because each hour has 60 minutes. We change this one to be hour. So that's the 4 3/4. Right, 4 3/4. 4 times 4, 16, plus 3, that's 19. That's 19 over 4, or use decimal 4.75. I like to use fraction form. Right? So that means h of 19 over 4, we just plug into the function. Square root of 30 minus 2 times time, 2 times t, 19 over 4. Right? So it needs to be square root of 30 minus 19 over 2. Or we want to change 30 to have the common denominator of 2. So we write 30 as 60 divided by 2 minus 19 over 2. Now we can combine those two numbers. 60 minus 19, that's 41. So it's the square root of 41. Right? You could use your calculators to do the calculation. Anyone has any question for this? So this just plug in, right? Evaluate. Let's say 2. Whenever when we talk about function, we care about the domain of the function, which means what kind of x value works for the function. With the square root, with the index being even number, we have to be careful with the negatives, because if the index is an even number, that radicand cannot be negative. So when the index n is an even number, and the radicand a has to be at least 0, cannot be negative. But when the index is odd number, that's okay. A can be anything. Let's see this example. We want to find the domain of this function, right? So how do we find the domain? So this is square root sign. The index is 2. Index 2 means the inside the radicand x plus 3 has to be at least 0. Or we write like this: x plus 3 greater than or equal to 0. So this means x plus 3 cannot be negative. Then we solve this inequality. We get x has to be greater than or equal to -3. If we use interval notation to represent the solution is an infinite number set. Starts from -3, goes up to past infinity. So that's the domain of this function. Anyone has any question? So you see, we just take the radicand, we set to be greater than or equal to 0, then solve for the variable. That's the step. So let's see this one. Square root of x plus 3. So take x plus 3 greater than or equal to 0. So that means x greater than or equal to -3. We take a 3 plus 2t greater than or equal to 0. Then we try to solve this. That's 2t greater than or equal to -3. That means t has to be greater than or equal to -3/2. Or we use interval notation. The solution set starts with -3/2, goes up to infinity. Anyone has any question? See, this one same, right? We take the radicand, which is 3 minus 2t, we set to be greater than or equal to 0. Then we subtract 3 on both sides. We divide by -2. Remember, when we divide by a negative number, we flip the signs. Greater than or equal to becomes now less than or equal to. Let's see this one. So the radicand is 2 over x. So we take 2 over x, we set to be greater than or equal to 0. Right? Then we multiply. Oh, we cannot do that, right? 2 is a positive. That means x has to be positive, right? So that's it. The solution set is x has to be positive. Okay, does this make sense? This is basically a little bit of analysis. The numerator is positive, the denominator has to be positive. This one, take the radicand, we set to be greater than or equal to 0. Right? Then the numerator is positive, so the denominator has to be positive. The denominator has to be non-negative. That means x has to be greater than 1. Okay. X has to be greater than 1, which means we can write in the interval notation 1 up to past infinity. But if index is an odd number, in this example is 3, odd number, it's okay. The domain is all real number, all right? Because it can handle negative. If this index is an odd number, the domain of the variable x can be any number. Okay, we check the domain only when the index number is even. Anyone has any questions? So basically today we talk about how to solve radical equations, right? When it has involved the square root sign, we would single out the square root term, then raise both sides by square. We may encounter extraneous solution, which is a fixed solution. That's why once we solve the equation, we need to go back to check to see any of the solutions is extraneous solution. Anyone has any questions? If the index is odd, we don't have any restrictions, right? Only when index of the radical sign is even, we have to be careful. Okay, anyone has any question? If not, I'm going to talk about exam on this weekend. It'll be the same thing. It'll open approximately the similar time. Okay, so exam 2 opens, I think it opens early morning, then close Sunday night, right? So the same policy, you pick 2 hours in those 2 days. Once you start, you cannot pause. And then there's a practice exam, practice problems, okay, which due is before the exam date on Friday. Make sure you do the practice, all right? Practice, let me hit the practice. So you still have time to do today, tomorrow, Wednesday. Wednesday we're going to meet again. If you have any questions, you can ask. And also, if you have any questions, you can ask today also. And by the way, this semester is we're finishing up this semester. How many classes we have? So Thursday, 1, 2, 3, 4, 5, 6, 7. We have 7 class time. We probably don't need this many because we are ahead of our calendar. We may finish early, so you can use more time to review for your final. Final is on campus. I remember it's on 19th. Yeah, final, what I remember is on 19th. You know, whenever I have the exact information, I will post on Blackboard right away. I don't have the exact, room and dates and time yet. Once I have, I'll let you know right away. So for now, what's important is this exam 2 practice problems, all right? Make sure you know how to do every one of them. If you master this, you master your second exam. There are 31 questions in total. Okay, I'm going to